What's up, guys? I'm going to teach you about the law of sines. The law of sines basically shows that the proportion of sine A to the side A is equal to the sine B over B equal to sine C over C. There's three cases. Two are super easy. Angle side and angle side angle are the two super easy ones. Those won't take too long to learn. And then there's the ambiguous case, which is side angle, and that takes a little bit longer, but after this video you'll know how to do it. Alright, we're gonna take it out with angle side to start, and this one's pretty easy. The measurement of angle A is 36 degrees and the measurement of angle C is 48 degrees. Then they give you the side length A, and that's 8. So right off the bat, you know that you can solve for the measurement of angle B, because you can the triangle is going to be 180 degrees. So then you add together 36 and 48 to get 84, and then subtract 84 from 180. So then you have the measurement of angle B is 96 degrees. And with that information, you can move on to try to find the length of side B. So you make the proportion of the sine of 96 degrees over B is equal to the sine of 36 over 8. And after that, you cross multiply. So then you get 7.956 is equal to 0.588 B. You divide that out, and you get the length of side B is 13.53. So that's pretty simple. And then you do the same process to find the length of side C. So this one I did sine of 36 over A is equal to the sine of 48 over C. 5.945 equals to 0.588 C, and then you divide that out again and get C is equal to 10.11. And then for this one, it's like a very, very similar process of angle side angle. We're given that the measurement of angle A is 40 degrees, measurement of angle B is 60 degrees, and the length of side C is 5. So once again, I started off by finding the last angle measurement, and I did the same process of adding the two measurements together and subtracting it from 180. So 40 plus 60 equals 100. 180 minus 100 equals 80. So measure of angle C is 80 degrees. Then I did cross multiplying again. The sine of 80 over 5 is equal to the sine of 40 over A, and you get 3.214 equal to 0.985A. Divide that out, and you'll get A equals 3.263. You basically do the same process again with the sine of 80 over 5 equal to the sine of 60 over B. You get 4.33 equal to 0.985B, and then you divide that out, and you get B equals 4.396, and so that'll get you all the measurements and all the side lengths you need to solve these triangles. And Migos will help with that.
Go.
All right, the third case is probably the hardest one. It's side angle. It's also known as the ambiguous case. There's like 6 rules you have to follow to solve these ones correctly. The first rule is if angle A is acute and the side length A is less than the height of the triangle, that means there's going to be no triangle. It doesn't exist. Like it just proportionally won't work out. And then rule 2 is if angle A is acute and A is equal to the height, one triangle exists. This is a right triangle. It's the 45-45-90 triangle. Everyone's familiar with that. Angle A is acute, and angle A is greater than B. One triangle exists. It's still, you can just see the triangle right there. The height is less than A, so you'll see that in the next one too. Angle A is acute, and the height is less than A, but A is still less than B. That's the trickiest one. That's when there's two triangles. There's an acute form of the triangle and an obtuse form, and that's what this problem is right here, and I'll show you that later. Rule number 5 is angle A is obtuse and the side length A is less than side length B, or A is equal to B, and no triangle exists there either. And then angle A is obtuse and side length A is greater than side B. One triangle exists, and it would look something along the lines of that. But before you solve this, like, you're gonna have to, the height has to be less than the side length. So for that formula, you're going to use h equals b times the sine of a. So I started off with the given information I had here. The measure of angle A is 26.3 degrees. Side length A is 7, and side length B is 8. I know that drawing is pretty terrible, but I just kind of like sketched a triangle and didn't think about the measurements until afterwards. So sorry about that. So I set it up, and I tried to solve for the acute triangle first, which would be the bigger one. So I did the sine of 26.3 over 7 equal to the sine of b over 8. So I got 3.545 is equal to the sine 7b, which came out to 0.506 equals sine b. So to get that, you do the inverse of sine 0.506, and that'll get you the measure of angle b, and that turns out to be 30.39 degrees. And then using what we did earlier, I added what my given side A was, or the measurement of angle A was, and 30.39 got 56.69. And then I subtracted 180 minus 56.69 and got 123.31 degrees. And then I once again did the proportion to figure out the side length C. So that got me to sine of 26.3 over 7 is equal to 123.31 over C. And that came out to 0.443 C is equal to 0.58 or 5849. And when you divide that out, it comes out to the side length of C is 13.2. And then once you learn this, you can solve for the obtuse end of the triangle. So to do that, you're gonna have 180. You're gonna subtract what you found for your measure of angle B. So I subtracted 30.39 off of 180 and got 149.61. So that's the acute measurement of angle B, and that would be this, like in this dotted triangle right here. And then once I did that, I added 149 plus 26.3 because I was given that angle, and that got me 175.91. And when I took that from 180, I was left with 4.09, and that's the measure of angle C. And then once you have that, you once again set up the proportion. So I had the sine of 149.61 over 8 is equal to the sine of 4.09 over C, and that comes out to 0.505 C is equal to 0.570. And then I divided that by 0.505, and I got C equals 1.13. And like if you just like look at the triangle in your head, that'll make sense. For the acute one, C is obviously going to be a lot bigger because it spans from here to here. So for the first one was 13.2, and then when you switch this side in all the way over here, you get it's a smaller triangle, and when B comes at an acute angle, the side C is only from here to here, so that's obviously going to be a lot smaller. And we knew the height was smaller than the side A, because that came out to 3.545, and 7 is less than 8, so we knew it fit the two triangle system. So you just have to work through this, and you'll find measurements for two separate triangles.